Look at this. Our next lesson is just for every single one of you because you are all our special angels.
Okay.
Hey.
This is so awkward. It's actually pronounced angles.
Oh, ox. Well, you're all of our special angles then.
Yeah, because you're all so cute.
Aww, that's precious. Well, let's look at some special triangles. We're going to consider a right triangle that has another angle measuring 45 degrees. And we can draw that, and let's figure out what we know about that triangle. So, here it be. Whoop. Think I lined this all up properly? Like a boss.
Dang, that's nice.
It's
You did that
profesh.
freehand?
Yeah, I did.
Okay, I can tell that
Except for
freehand.
that. Yeah, that was different.
Okay.
Alright, so we've got that 90-degree angle. It has another angle that measures 45 degrees. What else could we possibly know about this triangle? Well, there's something else we could find out, and that's this remaining angle here. And that angle's measure would have to be 90 minus, 180 minus 90 minus 45, since all three angles add up to 45, or all angles add up to 180. And the result of that would be 45 degrees, which is interesting because that makes this an isosceles triangle. If two angles are same, then the triangle is isosceles, and two sides, the sides opposite those angles, must also be same. So if those two sides are same, then we can give them labels. Let's just quickly write down the information we've got so far. So, the last angle must also be 45 degrees. That's a bullet point. And now we've discovered that the triangle must be isosceles. I don't know when I last wrote the word isosceles. I'm sure that's how it's spelled. And since it's isosceles, two sides are the same length. When we look at that and how that affects this triangle, it means we can actually pretend we're dealing with specific side lengths here. For example, I could say this is 7 and this is 7 because they'd have to be same. Or I could say this is 40 and this also has to be 40 because they're same. Or I could say this is 2 and this is 2, again because those sides are same. But what's easiest is if we say we have a very special particular case.
So, let's say that one of these two side lengths has a length of 1. So if this guy has a length of 1, that means the other one has to have a length of 1. Now, using that information, we can actually find the exact values of tan of 45 degrees, cosine of 45 degrees, and sine of 45 degrees. But of course, in doing that, we will need to also have the value of our hypotenuse. And we can find the value of our hypotenuse using Pythagorean Theorem. Okay, so in that, we know that a squared plus b squared is c squared. So 1 squared plus 1 squared is, I guess I could call this guy c, is my c squared. Which means 1 squared and 1 squared, well that's 1 plus 1, which is 2. Which means c is equal to the square root of 2. And notice it said exact values. If I plug into my calculator the square root of 2, I'm going to get this big honkin' decimal. And in fact, that decimal never ends. Your calculator just runs out of room. So, we're not going to write it in decimal form because it does specify exact values. So we're going to leave it as the square root of 2.
So we're not writing 1.4.
Exactly. So now that we have our side lengths, we can write out our tan of 45 degrees, our cosine of 45 degrees, and our sine of 45 degrees. And looking at this, it doesn't matter which 45-degree angle you choose, you will get the same result. So if we're looking at this guy here, this one would be considered my opposite, this other one would be considered my adjacent, and this root 2 would be my hypotenuse. If I looked at it from the other perspective, just for funsies here, this would be my opposite, this would be my adjacent, and this would be my hypotenuse. Notice that the value of my adjacent, regardless of what 45-degree angle you look at, is still 1. The value of my opposite is still 1. The value of my hypotenuse is always root 2. So it doesn't actually matter what perspective you look at it from, whether you look at it from this 45 degrees or this 45 degrees. It'll all be same. So let's take a look here. So tan of 45. So tan is my opposite over my adjacent, which is my 1 over 1, which can be simplified to tan of 45 degrees is just straight up 1. Now, my cosine of 45 degrees, that's my adjacent over my hypotenuse. My adjacent is 1, my hypotenuse is root 2. And there you have it, folks. Cosine of 45 degrees is 1 over root 2. And last but not least, we could do the same for sine of 45, and that's my opposite over my hypotenuse. My opposite's 1, my hypotenuse is root 2, and ooh, baby, look what we have here, 1 over root 2. So we can figure out the exact values of all of our trig ratios for the angle of 45 degrees. Neat.
Now, in some previous examples and previous lessons, we've used the value sine of 30 degrees. Immediately in my memory, I know that we saw it in multi-triangle problems in the very first example. What is the value of sine 30? If you put this into a calculator, so from a calculator, we can get that sine of 30 degrees equals 0.5. Or we could say that the sine of 30 degrees equals 1 over 2. What does this tell us about a right triangle that also has an angle measuring 30 degrees? Well, if we know that sine of an angle is opposite over hypotenuse, we can then say, sorry sis, math is way more important. So, opposite over hypotenuse is 1 over 2. This tells us that the ratio between the opposite side and the hypotenuse is 1 to 2. So the hypotenuse is twice as long as the opposite side. Wow, that's pretty wicked.
All right, so we're actually going to look at a triangle with a 30-degree angle, a right triangle with a 30-degree angle. So let's go ahead and draw that. So I'm going to start with drawing my 30-degree angle, which is, I don't know, maybe ish there. Let's see if I can connect them. Okay.
Pretty dope.
And so this one here is going to be my 30 degrees. I, of course, have my 90 degrees. But what is this missing angle? Well, the question just straight up tells us it's 60 degrees. But we know that because it's 180 degrees minus my 90 minus my 30, which would be giving me 60 degrees left over. Now, on the previous page, you just told us that sine of 30 degrees was 1/2, which means my opposite side of 30 degrees, so if I'm looking at 30 degrees, this one here is my opposite. This one here is my hypotenuse. This one here is my adjacent. My opposite side would be having the value of 1. And my hypotenuse would have the value of 2, right? Because sine of theta is opposite over hypotenuse. And you just said sine of 30 degrees is 1 over 2. That's where those values are coming from. Now, what it's asking us to determine is the value of the primary trigonometric ratios for the 30-degree angle, but as well as for the 60-degree angle. So we want to say what's sine of 30 degrees, what's tan of 30 degrees, what's cosine of 30 degrees. And then we're going to do the same for our 60-degree angle. So I'm going to get rid of this guy here. Nope. Delete. Hit the wrong button. There we go. So we've actually already figured out our sine of 30 degrees. That's pretty good. We'll leave it there. But to figure out our tan and our cosine, well, we're going to need to know the value of that adjacent. So what we're going to do is we're going to be using our Pythagorean Theorem. So we know that a squared plus b squared is equal to c squared. And in this case, we will have our adjacent, let's just call that x squared, plus 1 squared is equal to 2 squared, which gives us this. Moving all our variables to one side, we get x squared is equal to 3, so x itself will be equal to the square root of 3. So our adjacent side will be the square root of 3. Whoo, baby. Now, continuing on for the trigonometric ratios, we can now figure out our cosine of 30 degrees. We know cosine is our adjacent over hypotenuse. Our adjacent is the square root of 3. Our hypotenuse is 2. Square root of 3 and 2. Looking at the tangent of 30 degrees, we have our opposite, which is 1, and our adjacent, which is root 3. We could do same for our 60-degree angle. Whoop, I'm just going to move this guy over, if I can. And we'll just cruise through it. So if I'm looking now in relation to my 60 degrees, my root 3 is now going to be considered my opposite. My 1 is now going to be considered my adjacent, and my 2 is still, as always will be, my hypotenuse. So, going ahead and looking at these values, we have sine of 60 degrees being opposite over hypotenuse, being root 3 over 2. My cosine of 60 degrees being adjacent over hypotenuse will be 1/2. And the tan of 60 degrees being my opposite over adjacent will be root 3 over 1. But we can reduce that to not get the E1 error to have just root 3. Okay? So by using or knowing these special triangles, we can actually figure out the exact values for the trigonometric ratios for our 45-degree angle, our 30-degree angle, and our 60-degree angle. And these angles are considered to be special angles. All right. So you should be able to, at any given point, be able to reproduce those triangles to determine the trigonometric ratios for those values. So it's going to be really, really important that, I guess, the one that you have to memorize is sine of 30 degrees is 1/2. But otherwise, you should be able to get those values just the same. You could do it. I believe in you. There's some practice here just to kind of get your brains a-going. But otherwise, that's it. That's all. Woo! Adios, muchachos.
Goodbye.